So my presentation has to do with metaphor identification and interpretation when we're dealing with NLP, with natural language processing and large language models. Okay, I know that metaphor is kind of a challenging task. So in your presentation, Pavlos, I would very much like to see what you asked ChatGPT and it was able to compute sentiment analysis, because emotions are a huge deal in metaphor, in the work that we do with metaphor. Okay. So as a brief introduction, I want to say a few things about metaphor. So we consider metaphor for us as a figurative device that allows us to portray one domain, an abstract domain, in terms of a more concrete domain. Okay, it's no longer an ornamental device that we find in literature and poetry, and it's there because it sounds more poetic and scholar. Okay, so it's a conceptual thing. We talk in terms of metaphor. Okay, we feel in terms of metaphor, and we acquire metaphor while we're acquiring our first language as babies. Okay, so a couple of examples. If I say your claims are indefensible or he attacked my argument, I'm using indefensible and attacked, and these are used metaphorically. They are part of the domain of war. However, I'm talking about arguments. So I am constructing the metaphor argument is war. Okay, and this is perfectly understood by the listener in a conversation. So I have this cross-domain associations and comparisons, which we call mappings. And through these, metaphor enables us to communicate a complex abstract concept, to convey our affective states, to reinforce our arguments, and ultimately forge entirely novel word meanings. Okay, disclaimer here, novelty is the most challenging part that we have to deal with in NLP with regard to metaphor. Okay. I also like to say that metaphor is ubiquitous in language, is universal across languages. Okay. It occurs in average, let's say in every 3 sentences or something, according to different corpus linguistic research that has been done over the years, which means that accurate interpretation of metaphorical language is essential for many NLP tasks and application. And in the context of NLP, metaphor is a relatively understudied topic, and it remains an open question as to how well language models can interpret non-literal phrases. So, in the search for metaphor, what we find is different systems and how they work with metaphorical analysis. Sorry. So Shutova, in a couple of years ago, she did a wonderful, a very comprehensive review of existing metaphor processing systems. And since then, automated metaphor processing has shifted focus towards more neural approaches, including 2 shared tasks that took place in 2018 and 2020. And this systematic survey, this systematic review yielded some very useful conclusions. One of them is that the NLP applications tend to divide metaphor processing into 2 subtasks. One is to identify the metaphor, and the other one is to interpret the metaphor. And these 2 shared tasks encourage the use of a common task definition and particular metaphor corpora for the development of a metaphor identification system. To this end, though, very little discussion is available about whether or better yet, how well and to what degree the existing systems can address theoretical and cognitive considerations when it comes to the use of metaphor, and how insights and models produced in a general discourse could inform and benefit the wider natural language understanding research. What I mean is that we spent our morning today, and it was very fruitful and beneficial for everyone, but how can we actually put this into practice? Okay, all of these things we're saying, how can they be interpreted into code, into improvements of applications, of NLP applications? And I also want to say here that I'm talking about metaphor, all right, but essentially it's not just metaphor, it's all figurative means, the whole realm of non-literal mechanisms, irony, sarcasm, metonymy, and so on and so forth, figures of speech which have not been discussed at all, and they are very, and research on them is quite limited. Okay, so after reviewing recent advances in metaphor processing within contemporary theories of metaphors, social linguistic aspects, and what NLP applications actually need in order to work, we get the following questions. How are social aspects of metaphor treated, as in extended metaphors, metaphoric framing, intent behind metaphor use, and so on? Example, metaphoric framing is what political speeches employ. So it would be very interesting to see what ChatGPT yielded in Pavlov's research. Also, what can be done to improve all of those under-addressed tasks of metaphor interpretation and generation? There is great work being done, but still needs a lot more data and a lot more work in other languages other than English, right? And also how elements of metaphor can be integrated in the real world applications, such as machine translation, opinion mining, dialogue modeling, modeling argumentative discourse, and so on and so on. All right. Now, how do we account for metaphor? Okay, as I told you before, it's not decoration. Okay, it's not. There used to be this opinion, this view that the people who used metaphors were some sort of a brainiac, of a scholar using metaphors while they were talking or writing, and it's far from it. Metaphor is a mode of thought. So the conceptual metaphor theory, CMT, I will be calling it from now on, considers metaphor to be a conceptual operation. It's a cognitive mechanism that establishes cross-domain mappings in our conceptual system. It is a natural feature of thought, and Lakoff has been calling it a mode of thought. It's not a figurative device, which for many years in the past has been considered an exclusivity of language. This is for another time that we can discuss. Metaphors exist outside of language as well. They exist in visual representations, in auditory representations, gestures, and many more modes, but that's a discussion for another time. Now, in Lakoff and Johnson, the authors argue that the human conceptual system is structured metaphorically, and every abstract notion is conceptualized in terms of a concrete experience, which either pertains to the human body, something that we call embodiment, or to other domains of experience. Example, let's say that we have certain embodied metaphors, such as anger is heat, which have been found to be universal across cultures. Okay, for example, in Greek, we would say, when someone is really angry, fudosa. Okay, we conceptualize our anger as being hit inside our body. Okay, in English, we would say he blew his lid. Okay, and these are also conventionalized metaphors. I mean, we use them and we understand them in any context, right? But I can also have a kind of a novel metaphor if I talk about anger and say about someone who's like super triggered. I can say in Greek, ο Γιώργος είναι χύτρα που βράζει. Okay, θα πετάξει τη βαλβίδα κάποια στιγμή. And you understand that I'm talking about Yorgos, who's a very angry person. So my metaphor is grounded on domains of experience very much related to the human body. Positive experiences, another example, are metaphorized in the upper part of verticality, whereas negative ones are metaphorically down. Και πάρα πολύ με έριξε αυτό το βίντεο που είδα, meaning my feelings. I'm not feeling very okay with this. Emotional vicinity is warm, but distance is cold. Metaphor then draws from our sensory motor experiential basis, and not only, but mostly, allowing humans to experience the metaphor, okay, to feel the metaphor. Sorry, linguistic metaphors now, informed by conceptual metaphor theory, Steen, his work and his colleagues' work is very largely used among people who work, scholars who work within AI. A decade and so ago, he proposed a metaphor identification procedure, okay, the MIPVU, which is a method to identify metaphor-related words in a text manually. Okay, these MRWs, these metaphor-related words, are words that can be attributed to underlying conceptual metaphors, such as indirect metaphors, direct metaphors, implicit metaphors, metaphor flags, and so on and so on. I'm not going to go into detail in these, but I just want to say that Steen's work, the MIP, is quite possibly used, I don't want to say exclusively, but too much when structuring, when developing NLP programs, NLP models, okay? And I'm not saying that it's a bad thing, okay? His work is fantastic, but it has been subject to criticism. And those points of criticism should be addressed at some point, okay? Because employing the MIPVU in order to develop and improve, let's say, or fine-tune a large language model could have kind of a significant, substantial percentage of not yielding a proper result. Metaphor comprehension now, there has been a debate about whether metaphor comprehension is a comparison or categorization process, and how is this translated, interpreted when it comes to NLP, right? So in comparison, when according to the comparison view, when one processes a metaphor, what they do is search for the shared properties and the relational structures of the two domains. For example, let's say that I have this: beauty is but a flower which wrinkles will devour. Okay, so if I look at it the comparison way, being pleasing to the eye for beauty and flower and fragility, those are shared properties. In categorization, and for scholars who advocate the categorization view, they would argue that the object flower refers to this superordinate category that both beauty and flower belong to. In the career of metaphor theory, okay, it suggests that both comparison and categorization are possible paths of metaphor processing. And the decision on which path is chosen depends on interaction between the conventionality of metaphor and this linguistic realization. More specifically, novel metaphors are processed through comparison, and while a metaphor starts to become conventionalized, people tend to process it through categorization. Why? This is because categorization is a less cognitively demanding process as opposed to comparison. Now, I've been using the terms conventional and novel. I'm pretty sure you understand, but just a note: if a metaphor is entrenched into our conceptual system, then it is termed conventional. Just like the example I've given you before, if I say φουδοσαπτωθυμόμουν, that's a conventional metaphor, okay? But if I create an entirely new metaphor which would be understood by the audience, okay, because it is based on an existing conceptual metaphor, then that would be novel, okay? If it starts to be widely used, then it starts to become conventionalized. Now, data sets. Okay, NLP applications have been using data sets in order to train the models. Of the 4 data sets I have here, perhaps the most interesting is, and the most widely used, I told you before, is the last one, but I'm going to go very briefly through the other 3. So for annotations, the TSV data set, which consists of an equal number of metaphorical and non-metaphorical adjective noun phrases, was collected from the web. Another data set consisting of close to 1,600 sentences, most of them literal, few of them metaphorical. They were extracted from WordNet. Metaphoristic annotation here was obtained through crowdsourcing. The language-computer cooperation metaphor contained linguistic metaphors extracted from web corpora for a language other than English, contain English obviously, but also Spanish, Russian, and Farsi. And it was annotated at sentence level. The conceptual metaphors and effect information was specified. The VUA Amsterdam Metaphor Corpus, which is the corpus used by Steen and his team for MIPVU, is the fruit of the author's application. Because the metaphoricity of each lexical unit, which is a very large number of units compared to all of the other data sets, is a subset of the British National Corpus was annotated. And quite possibly this data set is the only metaphor corpus that was used for automated metaphor identification that was built by cognitive linguists, and the only one that deals with the metaphoricity of function words. Function words and content words could be used metaphorically anyway. Metaphor paraphrase data sets now, because paraphrasing has been used. Mohammed et al. In 2016 also obtained literal paraphrases of the sentences in which the metaphorically used verbs were replaced by their synonyms, and they were then selected by the authors. You should note that the literal paraphrases were considered to convey less emotion than the original metaphorical sentences in their experiment. This is an issue, okay, with emotion. This is why I'm very interested in sentiment analysis in those political speeches. It is therefore questionable to what extent the paraphrases can actually capture the connotation of the metaphorical sentence. Can it be a true paraphrase, in other words, or is it just an approximation of the meaning or the interpretation of the metaphorical sentence? Some years after, Bisoni and Lappet built a metaphor paraphrase dataset containing 200 sets of 5 sentences. 4 paraphrases at varying levels of aptness were provided for each metaphorical sentence, and apart from the verbs, the dataset also included adjectives, copula metaphors, multi-word metaphors, so it was kind of extensive. It took into account the connotations of the metaphorical sentences to some extent. Okay, for example, candidate paraphrases for "my job is a dream," which is a copula metaphor, "my job's a dream," include "I love my job" and "I hate my job," which are opposite sentiment poles. And the conclusion from that was that any metaphor processing system should be able to infer the sentiment to select the apt paraphrase. Now, recent metaphor processing systems for automated metaphor identification, most neural models treat metaphor identification as a sequence labeling task, outputting a sequence of metaphoricity labels for a sequence of input words, usually a sentence. The first sequence labeling systems typically represented an input sentence as a sequence of pre-trained word embeddings and produce a task and context-specific sentence representation through bidirectional long short-term memory. The most recent systems also adopt a fine-tuning approach, employing pre-trained conceptual language models such as the BERT and Roberta models. And from what I know, there is very recent research on how to fine-tune these models, like in what way specifically, in order to yield a more accurate result when it comes to metaphor interpretation. This is a table of all the recent metaphor processing systems. I included just so that you can see how many of these systems use the MIPVU dataset, okay, and it's which means that we need a cognitive linguistic approach to how we construct our data set in order to train a language model. Okay. Now, modeling metaphor in discourse. Okay, so there are several recent approaches that have also incorporated wider discourse properties in their models. For example, Mu et al. In 2019 focused on the metaphoricity of verbs. And they did that by using general purpose word, sentence, and document embedding methods, skip thought to represent the surrounding paragraphs, and their system feeds into a gradient boosting decision tree classifier, a concatenation of 3 feature vectors representing first, the lemma of the target verb, second, its subject and direct object, and 3, its surrounding paragraph. Okay, and all the representations were learned from embedding methods. In another work by Dankers et al., they fine-tuned a BERT model that receives a discourse fragment as input. They used hierarchical attention, okay, which computes both token and sentence level attention. After the encoded layers achieved better performance than applying general attention to all tokens. Okay, and both Dankers and Mu and their teams, the conclusion from what they did is that they demonstrated the importance of context beyond sentence for word level metaphor identification. And you should note that the above systems use discourse to aid in detecting linguistic metaphors, whose metaphoricity is otherwise ambiguous, okay? But they do not monitor whether a metaphor is sustained throughout a fragment of discourse, a text. Thus, they are unlikely to be directly applicable to the identification of extended metaphor or a metaphoric frame, okay? For automated metaphor interpretation, recent research on automated metaphor interpretation followed Shatova in treating the problem as a paraphrasing task. Okay, Su et al. Proposed a property transfer process for the interpretation of copula metaphors in Chinese and English. And given a target source pair, the system would extract source domain properties from handcrafted databases represented as an adjective. It then would select the property that contributed the most to the semantic relatedness of the target source pair. Okay, just a little pause here. I have not gone into detail on what semantic relatedness is, but semantic distance is a very thought out process on which a lot of systems have been based on so far. It's not 100%, and it will probably never get there because of metaphors, but it's a very, very, very decent approach. So anyway, the resultant pair of target domain word and property is taken as interpretation of the copula metaphor. So if I have love is tied, okay, the conceptual metaphor. It is interpreted as the love is unstoppable. And then this means that in 2017, the work done by Stuart took into account the emergent meaning of metaphors. Another system by Mao et al. Performed both metaphor interpretation and identification, and they used the synonym or hypernym of the metaphoric target word, which matched context, and it was considered the literal counterpart of the target word. And the output interpretations were evaluated through an English-Chinese machine translation tasks. Words classified as metaphorically used were paraphrased prior to translation. This is interesting because it actually improved the accuracy of Google Translation and Bing Translation on the metaphorical sentences using the dataset, the MOH dataset. And the experiment thus demonstrated the value of metaphor interpretation for machine translation. And Pisoni and Lapin presented a neural model that detects paraphrases of sentences containing metaphor use, which was also quite successful. Now,
Vivian, αν μπορούμε σε λίγα λεπτά να ολοκληρώσουμε, γιατί...
Ναι. Okay. For metaphor identification, there is a limitation in metaphor studies, okay, in that the systems do not deal with different types of metaphors. We have MIPBU data set, which has a really high percentage of conventional metaphors, and this is what we only use. And this implies that the systems trained on the corpus may not capture conventional and novel metaphor uses equally well. It is the processing of novel metaphors that is a particular challenge for natural language understanding systems. And the current experimental setup does not allow us to benchmark metaphor identification systems in this ability explicitly. And the same goes for deliberate metaphor use, although the term deliberate metaphor also has a great deal of discussions behind it, but it is essential for modeling metaphor in communication, and it would apply to both conventional and novel metaphors. So, while we have been advancing in performance when it comes to word-level metaphor identification, identifying actual conceptual metaphors, extended metaphors, and framing, this has been quite ignored. And conceptual metaphors form the framework for both the extended metaphors and framing from a cognitive perspective, and these are the key for the intentional use of metaphor in communication. I don't know if I have more time or I should just wrap this up. I just want to say very briefly that for metaphor interpretation, it has been largely focused on how to paraphrase the metaphorical sentence in a literal way, losing a great deal of meaning while doing it, okay? So the emergent meaning is an integral part of metaphor comprehension, should be captured by a metaphor interpretation system. And one way to deal with the inference of a linguistic metaphor is to convert it to the task of a paraphrasing popular metaphors. To do that, we need data sets of the emergent meaning of a wide range of conceptual metaphors in whatever language we are trying to train the model, the NLP model, okay? We can get this data from psycholinguistic studies about emergent meaning, but also from existing corpora. In Greek, I'm not so sure how many exist and whether they are up to the task. Okay, so a more comprehensive model of metaphor interpretation would consider the complexity of a metaphor, which essentially arises from the social aspects of metaphor use, such as the various roles that metaphor plays in communication. In generation now, and I am done, that although we don't have a lot of explicit attempts at metaphor generation, it is likely to be an inherent part of existing natural language generation systems already. Like it's already happening, but on its own, because metaphorical use of function words, for example, is unavoidable. Like you cannot have anything without it. For example, the use of bright for the description of color is considered a metaphor, but it's the most frequent use of the adjective. So it's very likely that an NLG model that is data-driven uses the word bright as a metaphor without understanding that it is a metaphor. So it is thus in the intentional use of metaphors that the difficulty of metaphor generation lies. And the development of metaphor generation system relies on the modeling of metaphor use in communication. Now in NLP, where this applies and how does it change our world is that automated processing of metaphors is indispensable. We need to use it for many NLP applications. There has not been a lot of discussion on the form of metaphor interpretation that would be most beneficial for NLP tasks. Consider, for example, machine translation. Okay, after obtaining an internal representation of a metaphorical sentence, a machine translation system can search for a literal or metaphorical expression in the target language that best matches that representation. And to do that, we have to investigate the hidden states of existing deep learning models of metaphor identification, and the vectors used to output metaphoricity labels may already be capturing the emergent meaning of the input sentences or not, but in any case, we need to check. In communication, I just want to say that given the relationship between metaphor and persuasiveness, it could be very beneficial to model metaphor using different types of argumentative discourse, such as political speeches, news articles, and so on. There has been some work done on that already. And some concluding remarks is that after reviewing the existing systems and how they work and how well they work, we find that there are less explored aspects pertaining to the cognitive processing of metaphor, how it works in communication, and how it connects with other NLP applications. I think the most substantially useful study that has been done very, very recently by Di Stefano et al. Is that they fine-tuned LLMs to predict metaphor creativity, novelty. Okay, and that worked better than it used to, and it became, and the results were very, very close to human ratings, which means that the models are attending to something more than just elaboration of the responses. And that's a process of fine-tuning that we should definitely look into. So thank you. And if you have any questions, I'm all ears, okay?